Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at finding derivatives of trigonometric inverse functions using trigonometric substitution method. Now, we have question number 28. That is tangent inverse of the square root of 1 plus cos of x divided by 1 minus cos of x. So our objective here is to ensure that we make the expression in here to just be tangent of some angle. Now, so let's go ahead. So the first thing we know is that cos of 2x, the double angle identity. So cos of 2x is equals to cos square x minus sine square x. So we can use this identity as a basis for deriving the identity for these two expressions. So if cos square x is replaced with 1 minus sine square x, which is the Pythagorean identity, we will just have cos of 2x now to be 1 minus 2 sine square x. But what do we want? We are looking for 1 plus cos of x or 1 minus cos of x. Now, if this expression, if this sine 2 sine square x move on this side, becomes positive 2 sine square x, and then this is 1. If this cos of 2x move on this side, becomes negative cos of 2x. Now 1 minus cos of 2x and 1 minus cos of x and 1 minus cos of 2x are similar, but the angles are different. So we can divide both sides by 2, each angle now by 2, so that we get rid of this 2. So 2 sine square x over 2 is just equal to 1 minus cos of x. So wheresoever we see 1 minus cos of x, we're going to put 2 sine square x over 2. So 1 minus cos of x. Similarly, if we rewrite this cos square x and just replace this sine square x with its Pythagorean identity, that is 1 minus cos square x. Now, because of this negative, we have to put this in parentheses such that minus times this positive 1 will give us minus 1. Minus times minus will give us positive. So cos of 2x now will just be equal to 1 cos square x plus 1 cos square x is 2 cos square x minus 1. So if we send this 1 across the equal sign, we have 1 plus cos of 2x is equals to 2 cos square x. But the angle here is 2. The coefficient of this angle is 2. And that coefficient is 1. So we need to divide each angle by 2, like we did in the first one. So 1 plus cos of x is just equal to cos square x over 2. So 2 cos square x over 2 is equal to 1 plus cos of x. So now we go to the problem and substitute. So we do have y equals to tangent inverse of square root of, now the numerator 1 plus cos of x is just equal to 2 cos square x over 2, and then the denominator is 2 sine square x over 2. But if we simplify this expression, carry out these 2 first, and then we have tangent inverse of, now the both of them are square, so we can just rewrite it as cos of x over sine of x over 2, all raised to the power 2. So these two now can cancel the square root. So y equals to tangent inverse of cos of x over 2 or over sine of x over 2. So y equals to tangent inverse of, now cos over sine is cot of the angle. So this is the quotient identity for cotangent. So this is cot of x over 2. Now we needed this expression to have ended up into tangent, not cot, because we want a property such that tangent inverse of tangent of x to just be equal to x. But now we have cot. So what we can do, we can rewrite this cot in terms of tangent, thereby using the co-function identities. So we know that cot of pi by 2 minus x is equal to tangent of x, or tangent of pi by 2 minus x is equal to cot of x. So whatever way we can write this, so whatever case we have, either of these can work with it. So we have y now equals to tangent inverse of, so this cot is this. So it's now equal to this, right? But this tangent of x was, the coefficient here was just 1. Now this cot has a denominator of 2. So it means that this angle as well, we must divide it by 2. So if we are dealing with this one, it means cot of x over 2 will be equal to tangent of pi by 2 divided by x over 2. So if this was like 2x, this would have been cot of 2x equals to tangent of pi by 2 minus 2x. So this is tangent of pi by 2 minus x over 2. So y is just equal to pi by 2 minus x over 2. So let's find the derivative with respect to x, because we're asked to differentiate this expression with respect to x. So we have dy, the derivative of the function y with respect to x is just equal, now the first one is just 0, and the derivative of x is just equal to 1. So dy by dx is just minus 1 over 2. So this is how we find the derivative of tangent inverse of 1 plus cos of x or over 1 minus cos of x. In the next example, you will see how we will solve the reverse of this, that is tangent inverse of 1 minus cos of x divided by 1 plus cos of x, which in that case now, this will end up into tangent of some angle, and our final answer will just be positive 1 over 2. Thanks so much for watching. See you in our next lecture.